What is up, amigos? Today we're talking about how vertical motion of a car affects its aerodynamics. So when we test a car in a wind tunnel or in CFD or whatever, we assume that the car is steady. So it's just going along at a constant height from the road. It's not moving around at all. Now that's rarely the case because of various factors. For example, the road, there might be some bumps on there. The aerodynamic forces may move it up or down in a dynamic fashion. So how does that affect its aerodynamics? So first of all, there are two different general cases. The first one is where the entire car moves up and down together. So if the front moves up 5 millimeters, the rear moves up 5 millimeters too. If the car goes down 5 millimeters, again, the rear 5 millimeters as well. So this angle here doesn't change with respect to the incoming flow. The alternative case is where the front and rear change relative to each other as well. So this angle actually does change. So if the front moves up 5 millimeters, the back might move up maybe 1 or 2 millimeters or whatever it is. So let's talk about first when the entire car moves up in as one block, so the angle doesn't change. So in this particular case, the top half of the car isn't really affected too much by its aerodynamics. It is a little bit in terms of how much flow is siphoned off from the top to go underneath, as opposed to when the car is lower to the ground, less flow can go underneath, so more flow that's hitting will go over the top and the sides. That is one case there, but generally speaking, the top half is not really affected too much when we change the entire car up and down together. It's really the lower part. So let's say we put this car up 5 millimeters in total. Now we know from this video here that the car is incredibly sensitive to its ride height in terms of how much downforce and even drag it's producing. In terms of downforce, the closer you can get to the road, the more downforce that you'll be producing. And that is very much because you shove flow underneath, you have to accelerate it so the pressure has to drop, and that then results in the car being sucked down more. So if you put this car up 5 millimeters, let's say, it's not very much, only like this much, but that is enough to dramatically change its downforce. And if you do it dynamically, so it goes up 5 millimeters, down 5 millimeters, the downforce coefficient can change by about 20, 30, even 40%. And if you want to get more information on this general phenomenon, check out a paper called Aerodynamic Stability of Road Vehicles in Dynamic Pitching Motion. So anyway, as you move this car up, the downforce can drop by 20, 30, 40%. And if you put it back down, it doesn't mean that the downforce will go to the same value that you had before. So let's say to begin with, we had a downforce value or a drag coefficient, a downforce coefficient of, let's say, 0.27 at a certain height. You then put it up 5 millimeters, and that drops to 0.24. You then put it down 5 millimeters. That's not going to go back down to 0.27, unfortunately. There's a hysteresis effect. What you need to do is drop the car even further down and then rise it back up to get to the original value that you had. And that is partly because of the diffuser and partly because of the underbody. So if you move the car up, as I mentioned earlier, there is more flow going underneath, and that means that it's not going to accelerate as much. It doesn't have to be squeezed as much, and therefore the pressure won't be as low underneath. What's more, when you get to the diffuser here, you won't have as fast moving flow to work with, so that means that the diffuser won't be working the same way, so it's not going to kick up the flow nearly as much, and potentially it may not even have the flow attached around the diffuser region. And if you want to learn more about diffusers, check out this video here. So there is a massive hysteresis effect going on here, and that's what happens when the entire car moves up and down together. What about when we have the front and rear moving a little bit differently to each other? Well, for this, I actually want to draw the rest of the car and actually draw it quite quickly and fairly accurately, because there are some different effects that we need to consider. So we have the car along the road here, and we have the free stream flow coming in. First of all, let's talk about the underbody. So if we were to, let's say, pitch up the front, which is very much the case, it doesn't matter whether you're pitching up the front or pitching down the rear, they're approximately the same. There will be a difference in the average ride height, but overall, it's pretty much the same in general effects. So if you pitch up the front here, what happens is now the car is at an angle to the free stream flow, and depending on what's going on top, if you have higher pressure underneath because you have a little bit more flow stagnating here and low pressure on the top, that can increase the drag. Also, now that we have the diffuser, which is installed at a certain angle, let's say it's 5 degrees or whatever out of the factory, well, if you then pitch up the car a little bit, that diffuser is now at a lower angle. So now that's not going to work as well as before. What's more, you're going to have more flow coming in, and as you go along, it's going to have to accelerate more and more. So the underbody may not be working the same way in terms of you're going to get less lift, less downforce, sorry, at the front because the flow is not moving as fast and the pressure isn't as low. So that's the underbody. The top is also dramatically affected now because if you move the front up more than the rear, so the car's now at an angle, the front A pillar here is now less perpendicular to the incoming flow. The C pillar is more perpendicular, so it's more straight on to the flow. That means the A pillar, because it's more at an angle, the vortex off here is going to be weaker. The vortex off the C pillar here is going to be stronger. If you were to pitch the car down, so nose down, the opposite occurs where the A pillar gets stronger and the C pillar gets weaker. In addition to that, we know that this backflight angle here, which we've gone through in this video, is incredibly important in terms of determining when the flow will stay attached and when it won't. The greater this angle is, the more likely the flow won't stay attached. And actually in this week's video on Saturday, which is the 17th of August, 2024, we are going through the aerodynamics of a Subaru WRX, and it's really cool. We're going to see some really important effects of the back window and its aerodynamics. So check out that video, and if you're watching this after August 17th, 2024, check out the Subaru video as well, because you're going to see some really cool flow physics there. So anyway, so that in a nutshell is how vertical motion of a car affects its aerodynamics, both when the car is moving up and down together and when it's pitching as well. So if you like this video, make sure to click the like button and subscribe, and I'll see you on. Peace amigos.